Hello everyone, and welcome to your first official lesson of this tutorial. Here we're just going to become a bit more familiar with idle, which is how we're going to build and run our Python programs, and we're going to build a very simple input-output type Python program just so that you can get used to the flow of things. So go ahead and open up idle now. It should have been automatically installed with Python 3.6. If you're using a Mac, you should be able to find this under Launchpads in your applications folder. Simply select idle, and it will just open up a new window. Now things will look a little different if you're using a PC, as with the rest of the tutorial, but you should see Python 3.6.5 shell regardless of which program you're using. So this is what's called a Python shell, in which we can actually write and execute statements right away. Now this is great for kind of single line statements. For example, if I wanted to just print something out, I could say print, and then I could put in these quotes here, something like hello. If I press enter, it's just going to compile and run that line right away. Now what this isn't great for is writing multiple lines of code and then having them execute complex logic. For that we might need a new text file, and then we just run that text file rather than doing everything in the shell itself. So I'll show you how to set that up. Let me just kind of get myself set up here. We're just going to kind of open this up a little bit, and then we're just going to go into idle and we'll select a new file. Command N also creates a new file for us if we'd like to do things that way. So let's just expand this out. Okay, good stuff. Now it's usually a good idea to give your file a name right away. So I'm just going to go to File, with this window selected by the way. We're just going to go to File, we're going to go to Save As. And let's just give this guy a name. I'm going to call mine Hello, you'll see why very soon. And I'm just going to save it to the desktop. Okay, make sure it's a Python file with a py extension. Go ahead and click Save, and now it should have renamed your file up here. Now, if we want to do pretty much the same thing that we did here, what we could do is actually just run that same line of code. So just print something like hello. Okay, if I give this a save, make sure I save it and the asterisks will disappear. And then I go to this guy, make sure that this window is selected. We can go to Run Module, or just press F5. Okay, it will do pretty much the same thing. It restarts it, and then it just runs that file there. In this case, the results are exactly the same as with the first case. So that's great, but how is it different from just running it in the shell? Well, in our case, it isn't. What we can do is make this file a little more complex, and what we'll do in our case is actually have it take in some input from the user, and then do something with that input, and then produce some output. Okay, so the way in which we take input in a Python program is through the input function. I'll show you how to use that in just a second. Let's just call our input something like input name. Okay, and we're going to set this equal to the function called to input. We'll open up the parentheses beside it, and within these parentheses we're going to put a quote or a couple of quotation marks here, and then within these quotations we're going to enter the prompt for the user. So this will be something like enter a name with a space, and this will just be some kind of message to display the user, which will prompt them to actually enter some kind of text. Now what we'll do is we'll create another variable called output text, and this is just going to be something like, it'll be some quotes. It can say hello space and then plus whatever name that we entered, so input name. Okay, so we're just going to go ahead and give this a save. In our print statement, rather than just printing hello, we're actually going to print out our entire output text. So let's give this one final save, and before we run it, let's just quickly go over what will happen here. So this input function will basically prompt the user. It will print this to our console, and it will say enter a name. So the user will have to enter some text. They could enter no text if they want, and press enter. And then what this is going to do is it's going to save whatever text was entered in here. It's going to take this text here and it's going to stick whatever we enter here onto the end of this string. It's going to store it in output text, and then it's just going to execute this function, which will print whatever text is hello plus our input text, and it's just going to print it to the console. So it's easier to actually see what will happen once we run it. So we're going to again make sure this is saved. We'll go to our run window, run the module, and you can see here that it's prompting us to enter a name. So I'm going to enter my own name, press enter, and now it says hello Nimish. Now depending on which name you entered here, it will say hello and then the name you entered. If you enter no text, so if we go ahead and run this again, okay, and we entered no text, it's just going to say hello. So this is just a very simple input-output type program. Now, we don't actually have to run everything through the shell. If we really didn't want to use idle, what we could do is actually create any old file in any kind of a text editor, make sure it's saved as a Python file with a py extension, and then just run it through the terminal. So I'll show you how to do that really quickly. We're just going to open up terminal. Okay, and what you'll want to do is navigate to where you saved this file. So we'll still be working in idle, so this step isn't necessary. I guess you can consider it bonus, but it's good to know anyway. So in my case, my file here, hello.py, is saved at users/owl/desktop/hello.py. So what I'll need to do is change my current directory, because in my terminal here it's owl, this is the root directory I'm at. I'm going to need to change my directory to owl/desktop, because this is where the file is stored. So if I use the command cd desktop, okay, and press enter, you'll now see that my directory root is at desktop rather than just at owl, okay? So now if I use the command ls and press enter, this gives me a list of all of the directories and all of the files in my desktop. As you can see, my file here, hello.py, is in my desktop, and if I want to run this, I'll simply type in Python 3, because I'm running it through Python 3, and then I'm just going to type the name of the file, hello.py. Okay, and it is case sensitive, by the way, so you will need to enter the uppercase if that's how you named yours. If you press enter, it's going to do the same thing. It'll just prompt me to enter a name. If I enter my own name, press enter, then it's just going to say hello Nimish and finish the execution. Okay, so now you've seen two ways to run files. You could run your Python files through the idle shell itself, or you can run it through the terminal. Like I said, we're going to be using the shell, but this is good to know anyway. If you do want to run things through the terminal, just make sure that you do navigate to your folder by pressing or typing cd and then the directory name. And do this before you try to run your program, otherwise it's going to say likely it can't find the program. Okay, so that's how to run very simple input-output type programs written in Python through your idle shell. When we come back, we're going to start learning about our Python language basics, so hopefully all these different components will make a little more sense, and we're going to begin with the topic of variables. Hello everyone. Before we begin writing any code, it's a good idea to make sure we have the latest versions of Python and pygame as well. So in this section we're going to download and install both Python and pygame for Mac specifically. If you're using a PC, then we've actually done the same thing in a different video, so skip this, go ahead and watch that. It's going to be the same process, just obviously for Windows instead. So we're going to go ahead and open up a new browser. I have Chrome open, but you can open whichever one you'd like. And we're going to start by downloading Python. So simply search for download Python. We're going to click this first link, which is just python/downloads. And we're going to download version 3.6.5. 2.7.14 is still fine, but it's a little out of date. This has the latest stuff that we need. So we're just going to go ahead and click on this button, and it will download a package type file. Once this is done, simply go ahead and open it. Okay, and we're just going to follow these instructions here, starting with the intro, the readme, and then the history and license. Do make sure you actually read through this. I'm sure all of you will. Once that's done, we're going to go ahead, click continue, click agree, and then we'll be fine with this location unless you want it to be in a very specific place. Let's just go ahead and install that there. So you'll need to provide your permission. Okay, once that's done, we'll go ahead and install the software. Now, I believe I do have the latest version already, so this should be very quick for me. Otherwise, it should only take about a minute or so for you guys. So I'm just going to pause the recording until this is done. Alright, so now that this is finished, this window probably will have popped up, which gives you all of the main pieces of software that are installed with Python 3.6. Obviously there's a lot of other stuff as well, but just make sure that idle is here, as this is going to be the IDE that we'll be using. Okay, so you can close it up if you want. Just go ahead and click close here. Okay, we can move the installer to trash as we don't need that anymore. And now that we're done, we can download and install pygame. Now, seeing as we're using Python 3.6, the actual download that we want isn't found on the pygame site. So if I search for pygame download and go to pygame's main download site, I actually don't see the version that I want. What we'll want is 1.9.3, as this is the latest version, but for Macs, the latest version you can download from this site is 1.9.1, and that requires Python 2.7. That's not going to be the one that we'll want, so we'll actually have to do a little bit of work in the terminal. So what I want you to do is go ahead and open up a new instance of the terminal. If you press Command and space, this will bring up your search window, and we're just going to search for terminal. go ahead and click enter, and it will start a new window here. So what you'll want to do is go for Python 3. As we're using Python 3, we want to make sure that this is going to be the version that we'll use. Okay, we're going to go -m or -m, and then we're going to type pip install pygame, capital P, equals, double equals here, 1.9.3. So this is what it will look like in the end. So Python 3 -m pip install pygame equals 1.9.3. Note the double equals, and you will have to have the pip installed. I think it should be defaulted. It should have been installed by default, but if this command doesn't work for whatever reason, says pip is not a valid command or something, you will need to go ahead and install that. So once we go ahead and click enter, what this will do is it will install the latest version of Pygame into our Python 3 folder. Now for me, because I already have the latest version of Pygame, it actually says requirement already satisfied, but this should just take a few seconds, should show some kind of like installation bar, and it will guide you through the process. Should just take a few seconds, and if we want to check to see that that's done, what we can do is go ahead and open up Finder, and it should be saved under Macintosh HD. We'll want to go into Library, into Frameworks, want to go to Python Framework, versions 3.6, want to go into Library, all the way down to Python 3.6. If we scroll down to Site Packages, and then search for Pygame, it should be Pygame right around here. So there should be a Pygame folder, there should be Pygame-1.9.3 dist-info, and if you have these folders, that means the installation was successful. So that is how you get your hands on the latest versions of Python. Again, 3.6.5 is the one that we're using, and of Pygame, we're using 1.9.3 for this, although if you use the slightly earlier versions, it doesn't really matter that much. Now, the next video in this series is, I think, pretty much the same thing for Windows. If you are using a Mac and this went smoothly, you can skip ahead to the next section, which will start to explore the idle environment. Once that's done, we'll move on to Python basics, and that is pretty much all the setup that we need for this. Hello everyone, and welcome to our tutorial on how to install Python and Pygame for Windows 10. Now if you're using a different version of Windows, things might look a little different, although realistically you should be upgrading to the later versions anyway. So here I just have a new window of Chrome open. You can use whichever browser you'd want, and we're simply going to Google search for download Python. Okay, this should take us to the Python site if we follow this first link, python.org/downloads. So we'll simply click on this, and the version we want is 3.6.5. Now if you're watching this video much later than when I made it, you may have later versions like 3.6.6 or 0.7. Those are, just make sure you're downloading the later ones. We don't want any of the 2 versions, we do want the 3. So let's click on this, and it's just going to begin to download an executable file. So this should just take a few minutes, or a minute, or in this case a few seconds. So we're just going to go ahead and open this. It's probably stuck in your downloads folder if you can't see it here. We'll simply click on this. Okay, and it's going to pop up the installer for us. So smart screen can't be reached. Don't worry about that. We're just going to go ahead and run it anyway. So what we want to do is add this to our path, and then we're going to select this guy up here. Now this should download everything we need, idle, pip, and the documentation. It's going to create the shortcuts and file association, so we're just going to go ahead and click on this. Now the installer will take a few minutes to install everything, so I'm just going to pause the recording, and once it's finished, I'll come back and guide you through the rest of the process. Alright, so it looks like the setup was successful. We have it successfully downloaded and installed. It's just a matter of accessing it. So for this, we're actually going to just go to our search, and we're going to look for Python. We want Python 3.6, but we're not going to open this up because this will actually open up a terminal or a command prompt. We're going to right click here. We're going to open up the file location, and it should take us to this folder or this directory where we have a few items. We have idle. This is actually going to be the program that we're going to write our code in. If you want to take a look at what that looks like, go ahead and open it up, although we'll explore it more in the next section anyway. There is Python 3.6. This is just a way to run up a command prompt or a terminal. There's manuals and manual documents. So what we'll want to do is actually right click on this again, and we're going to go for open file location. And this should take us to a new file or a new directory. So within here we should have scripts. So we're going to go to our scripts folder, right click on that or double click on that, and you should see a bunch of easy installs, and there's the pip, so the Python packaging. I think it's something to do with Python packaging installer or something. And so we're not actually going to run these just yet. We're actually going to copy this file path. So if you right click on here, we're just going to select this all, and we're going to copy it. So Command C is just copying it. So next step is going to involve a little bit of terminal work. We're actually going to open up a command prompt. You can do cmd, terminal, either of them will open up the same thing. So we're just going to go ahead and open that up now. So you see it says C :users/user. We're actually going to right click here, and it should just paste that in as soon as we right click. If not, then just paste it in. We're going to click enter. Oh, actually, before we do, we need to go right to the beginning, and forgot the change directory command. So we're just going to go cd and then space and this. So cd is the command for changing the current working directory, so change directory. And so we're just going to change the directory to this path. So let's click enter, and now we're in this path here. So what we're going to do is we're going to select pip, or type rather pip install pygame. We're going to click enter, and this will start the installation of pygame. The great thing is that it will actually already download the latest version of pygame. In my case, I've actually already downloaded it, as you can see, requirement already satisfied. But if you haven't downloaded this, this will just take a few minutes to actually download it. So it should give you like a progress bar, tell you how far along it's done, and then once it's done, it will give you a command like this. Typically, it'll just prompt you to upgrade to the latest version of pip if you don't have the latest version. Otherwise, it should say pygame successfully installed, and it will be in our library site packages. Okay, so that's actually all you should need to do. From now onwards, we have access to pygame. I showed you how to install it for Macs earlier if you are using a Mac instead of a PC. And in the next tutorial, we're going to explore how to actually import pygame into idle and use it to create some pygame programs. Hello everyone, welcome back. Now that we know how to use idle to build and run Python programs, I figure we should start learning about the Python language syntax before we start using it to develop games. So over this section and the next several sections, we're going to talk about some Python language basics. We'll start with variables, where we'll explore basic syntax and take a look at the commonly used basic types. So just take a moment to get yourself set up with something similar to what I have going on. I've got my Python shell on the right hand side, and then just a new Python file. I've called mine variables_text.py. And I've just added some comments here. By the way, anything that is preceded by this pound sign is a comment, and so is ignored by the compiler. It's just there for us as the users to read. So for starters, what exactly are variables and how are they useful to us in the code? Well, variables are just a way to store a value or multiple values and associate them with a name. Now in Python, there's not so much the concept of constants versus variables, so these values can actually change. So let's say I assigned some kind of a number value to a variable. I could definitely change that later on, and weirdly enough in Python, I can actually change between different types. Now what I mean by this is that there are lots of different types that denote the kinds of values that a variable can hold. For example, these four basic ones, ints, floats, booleans, and strings, all hold different kinds of values. So ints are whole numbers, floats are decimal numbers, booleans are true or false values, and then strings are just any kind of text or message within the code. It's basically anything between these single or these double quotes. In Python, there's no differentiation. Now, when we're setting up variables, we actually don't have to define a type in Python. All we need to give is a name and then the value that we want. So let's say I wanted to represent some character's name. I could create a variable called name, and I could just assign it the value of, let's say, my own name here. And as long as it's between these single quotes, that's appropriate. Again, or you could use the double quotes if you want. Doesn't really matter. And that's it. I've created my first variable, and I can use this however I want. If I wanted to retrieve its value, I simply call on it. And if I wanted to change its value, I can reassign it to something else, some garbage text here. Or, weirdly enough, like I said, you can change between types, which is not something that you can do in most other languages. But I could assign this a numerical type, or let's say a false, that's a Boolean value. So Python is very, very flexible in that regard. Now there's also the concept of assigning the value of none, okay, which is a value in and of its own sense. What this means is that this variable has no value associated with it. It's kind of like null or nil that you might see in some other languages, but just means that we cannot use this variable to retrieve its value anymore because it has no value associated with it. Okay, so just be careful when assigning values of none, as incorrect use can often cause your program to crash. So let's take a quick look at each of these four types. we'll start with ints, and we'll try to relate these examples to kind of like video game development. So where might we use integers? Well, the first thing that comes to mind is when we're mapping positions. So let's say we have a very simple grid, just like x and y, and we're only moving left or right, so we're only really changing the x position. We might create a variable called xposition, or xpos for short, and I'm just going to assign this a value of, let's say, 5, whatever that would mean for our program. Well, in this case, the type is inferred to be an integer because it's a whole number. As soon as I add a decimal there, then the compiler thinks that it's a float. Okay, so we can actually change back and forth between the types as we've seen. So as soon as I do this, integer, and now it becomes a float. In my case, I might want this to remain an integer and then have something like speed. And I can set this equal to some kind of decimal number. So let's say 2.5 is moving left or right at 2.5 tiles or whatever per second. Okay, so integer, whole number, floats are decimal numbers. Let's take a quick look at booleans. So these are just true or false values, okay, kind of the equivalent of 1 or 0. And a good example of this might be checking to see if the game is over. So we might have a variable called isGameOver, and we'll just set this equal to false as long as the game is running, and then maybe something will happen, like we'll collide with a player, or we'll run out of lives or something, and then we can set this to true, and that will indicate that the game is over and we can carry out the endgame logic. So that is booleans for you. Now let's talk quickly about strings. Well, strings, again, anything between the single or double quotes, and are usually representative of text or messages or names within the code. So again, I might have my character name. Let's call this, just character name or something. And again, I'm just going to enter my own name for fun. What you don't want to do, by the way, is have a mix like this. Okay, it either needs to be just single or just double quotes. Now, just like before, all of these values can change at any point in time, and I can change the different types. If I'm ever unsure of the type of a variable, I can actually just call upon this type function, and then I could just put the variable name inside of it. So let's say xposition, I want to know the type of this, then I could just call on this, and it would return the type, in this case an integer. Now, let's say I want to actually print that out because I want to see visually what the type of it is. I can actually just encompass this whole thing, whoops, I'm missing the T there, inside of this print statement. Okay, if I give this a save and then I run this, then I should get the class of integer being printed out here, and that's exactly right because this is indeed an integer type variable. Weirdly enough, if I did this and then said something like xpos is equal to some text here, and then printed out the type again after the change, so let's give this a save and rerun it, then I should actually get string being printed out now. So it first prints out the type of integer, which is right, and then I change its type here to a string, and so the class is now string. Okay, so that's a very useful operator, function, the type function. If I wanted to just print out the value itself, then I could, rather than calling on type, just print out xposition. Okay, so save this, print it out, and I run it, and then it's just going to print out the value. In this case, it's just this garbage string that I assigned here. Okay, just note that once you reassign the value to a variable, that is now its new value for the rest of the program until you change its value somehow. Alright, so that's a quick intro to variable syntax and to the 4 basic types that we'll see. What I would encourage you to do is just play around with this a bit, try to think of another example, game related, where we might use an integer, a float, a boolean, or a string. And once you've done that, we'll move on to the next section where we'll start talking about operators and perform some operations on variables like this. Hello everyone, welcome to Python Language Basics Part 2. Hopefully you're comfortable enough with variables so that we can move on to perform some actual operations on these variables that we created. We'll divide the main groups of operators into 3 categories: assignment, arithmetic, and conditional, and although this won't cover everything that we can do, this will cover the most important and the most commonly used ones. So to start, let's look at our assignment operators. We've actually already used one of these in the previous 5 lines of code that we wrote, these ones. And it's just a way to assign a value on the right to some variable name on the left. We can assign what's called a literal value like this, or we can assign a variable's value by doing something like this. We could set, for example, xposition equal to speed, and that is equally valid. Xposition now holds a value of 2.5. So xpos equals 2.5. Now the not operator is maybe even simpler to use. It's just a way of negating a true or false value. So if I created a variable called something like is not game over and set this equal to not is game over, then this is just going to take whatever value it finds here, false, and it's just going to set it equal to true. Okay, so it's just going to print out true. By the way, if at any point in time you want to print out the variable's values, so pause it and then print something out to see what the results would be, you can totally do that. Just use your print statement and then the name of your variable, so is not game over, for example, and then this is just going to print whatever value it currently holds. Okay, so those are your basic assignment operators, fairly straightforward. Let's move to some arithmetic operators, a little more interesting. So arithmetic operators are fairly straightforward. It's just your basic addition, subtraction, multiplication, and division. We also have the modulus operator, which returns the remainder of division, the floor operator, which discards the remainder after performing the division, and then we have the kind of combination assignment arithmetic. I'll get to those in a second, and then we have the power or the exponent operator. It's a way to just introduce powers or exponents into the code. So I won't go through all of them. We'll just take a quick look at an example of the addition operator if we'd like. It's just a way to add values together, so I could maybe set my x position equal to something else, or maybe create a new x position. So I could say something like new x pos is equal to the current value of x pos, which, because we reassign it down here, is only 2.5, and let's say I want to increase my position by 5. So I could do something like this. If I wanted to increase it by speed, which honestly would make a bit more sense in our context, I could do that. And so now it would hold the value of 5. So the same goes for subtraction, multiplication, and division. I guess the only other thing I want to showcase with this is that we can add strings together. This is called appending one string onto the end of another, also known as concatenation. So if I wanted my full name, what I could do is say something like character name is equal to its current value. So actually, let's create a new variable like full name or something equal to character name plus, and then some other string. So I could have my last name here or something. Okay, and at this point, full name contains Nimish Narang. So something like this. Okay, so let's take a quick look at the modulus operator and the floor division, as those are a little more difficult. And so the modulus operator is again just going to return the remainder of some kind of division. So let's say I have some number. Let's say I want to assign my x position, which is equal to 2.5 to 5. So let's just do that really quickly. X position is back to 5. And let's say I want to find the modulus of 2. So if I take x position, actually let's call this mod x pos. Let's set this equal to 5 modulus 2. And now mod x pos will hold the value of 1. Okay, and the reason is because 5 divided by 2 is 2 with a remainder of 1, and so that's what gets returned. The floor division is pretty much the opposite, so let's say floor div x pos, which is 5 at this point, is just going to give me, let's do this is equal to x pos floor divide, let's say 2. This is now going to return me 2. Okay, and that's because again the 5 divided by 2 is going to be 2 with a remainder of 1, just discards that remainder, and so it gives us 2. So the exponent operator, also fairly easy to use. So let's just say something like x pos squared is going to be equal to my x pos, and we're going to raise it to the power of 2. So now it's just going to be equal to 25. Okay, very good. So where do the arithmetic and assignment combos come in handy? Well, this is very good for just kind of shortening the amount of time it takes to develop anything and just shortening the number of characters that we have to type. So let's say I want to take my current x position, which is 5 at this point in time, and I wanted to add 2 to it and then store that value back into x position. So rather than modifying the value and storing it somewhere else, I want to modify the value and store it right back into x position. I could do something like x pos is equal to x pos plus 5. Okay, that's fine. At this point it equals 10. Or I could do this, x pos plus equals 5. And that's going to do exactly the same thing as what I just erased. So this just takes its current value and then it performs this operation, so plus 5, and then stores that back into x position. And exactly the same logic goes for the divide equals. Let's say we had multiply equals, minus equals. It's all exactly the same. Okay, by the way, the same logic can be applied when you're concatenating strings. So with that said, I think we're just about done covering the basic arithmetic operators. Let's now move to conditional operators. So again, I'm not going to go over every single one of these because these are fairly straightforward. We have our greater than or equal to, less than or equal to, not equal to, and is equal to. So we've all seen these operations at some point in time. They just basically have typically two numbers, although we can actually do it with strings as well, one on the left, one on the right, and then they return a true or false value based on whether or not that's true. So if I had something like 5 greater than 2, obviously that's true, it's always going to be true. If I had something like 5 less than 2, that's going to be false. If I had 5 not equal to 2, that is true because 5 and 2 are not equal. And if I had 5 equal to 2, that is going to be false because these two values are not equal. So this is a way of testing value equality. This is a way of just assigning a new value. So it's important to note the difference between the two. Just keep in mind that these always return some true or false value. So if I said something like is true, created this variable called is true, and set this equal to 5 greater than 2, this is going to be true. Whereas if I set something like is true equal to 5 equal to 2, this is going to be false, obviously, because those values aren't equal. Alright, so those are your basic sets of operators that you'll see on a day-to-day basis. Again, this isn't everything, but this is enough for us to actually begin our game development. I think we'll use a lot of these, but not even all of them. It's just good to know how to use them all. So before you move to the next section, I would highly recommend that you do a little bit of practice on your own. Definitely be printing out values using your print function and just seeing what the results are. And once you're ready to move on, let's start learning about lists. And for that matter, a lot of other collection types too. Hello everyone, and welcome to Python Language Basics Part 3. Here we're going to switch track and talk about a new topic, which is going to be collections. We're going to study three major types, which will be tuples, arrays or lists, and dictionaries. Arrays and lists are actually quite the same in Python, but not all languages, by the way. And then we'll take a look at some examples throughout. So I started a new file here called collections_text.py. I've kept all the old source code that we wrote in the variables text one, and I'll continue to provide a new file for each of the major topics. This way we get to start from a clean slate and aren't rerunning all of that old code. So first of all, what are collections used for and how do we use them? Well, until this point, all of the variables that we've seen have only ever held one value at a time. Now that's fine, but if we want to store multiple values within a variable, we're going to need to turn to collections for that. And the benefit of doing this is that we can cast around multiple values in a single location and perform various operations on them. So we actually set them up pretty similarly to the variables. We have the name, equals, and then some value, except that we'd have typically a list of values. Now, the way in which they differentiate is the fact that, first of all, tuples are actually non-mutable, which means that they can store multiple values, but we cannot really modify them. We can't change individual values, and we can't add or remove elements from tuples. Arrays or lists kind of take it a little bit further. They're kind of like tuples, except that we can add elements to them, we can remove elements from them, we can modify individual elements within them. But dictionaries are quite a bit different in the sense that we don't really care about the index of where the elements are stored. We store values based on their key. So whereas with tuples, arrays, and lists, we kind of access the elements based on their index. So if we want the first element, we access index 0. If we want the second element, index 1, so on and so forth. With dictionaries, it's not really stored according to when you inserted an element into the dictionary. It's rather the key to which it was assigned. But we'll see more on this a little bit later towards the end. So let's start off with a basic tuple example, and I'm going to bring up the concept of an object size. So let's say we're developing some kind of a game. It's just going to be a 2D game. Everything within that game has to have some kind of a width and a height. So we could define two variables, such as a width of 100 and a height of, 200. That's fine. Or we could define a size tuple and set this equal to just 100 by 200. Now this is a little better because we know that a size is going to be a width and a height, and this way I can access both values just by calling on size. So if I print out my entire size tuple, I mean entire meaning there's only two elements in this case, and if I were to, oops, that's not the right key, if I were to go ahead and run this, okay, I'd get the whole tuple being printed out here, 100 and 200. By the way, that short key for running it is just holding the function key and pressing F5. That just compiles and runs your code. It's the same as going up here to run and then run module. Okay, so this is cool. I can access multiple elements at once, but what if I wanted to access just my width or just my height? Well, for that, I do so based on index again. So this is index 0, this is going to be my width, and I can store it in a width variable. Okay, whoops, if I can spell it properly. Width is going to be equal to this, and then I could set for example, my height equal to size of 1. And then if I wanted to print these out individually, it would just print out 100 and then 200 for this. Okay, pretty cool stuff. Now I said that we can't really add elements to tuples or remove elements from them. What we can do is reassign a tuple. So let's say I now want to consider 3 dimensions. I want my length as well. So I might try to store this in size, or what I could do is maybe create a new size tuple and set this equal to the current value of size plus some new values. So let's say I wanted a 300. But with tuples, weirdly enough, this doesn't count. If I just have one element in my tuple, I have to add the comma. Okay, so at this point, new size would be a 3-element tuple. So if I were to run this, I should get 3 elements being printed out now. So if I wanted to remove elements, well, I can't remove individual elements, nor can I modify individual elements. Instead, I would have to call on delete, new size, and at this point, it would just delete my entire tuple. So if I try to access it, it doesn't exist anymore because we just deleted it. Now there are various built-in operations that we can perform not only on tuples but actually arrays and lists and dictionaries as well. So let's say I wanted to find the length of a tuple. I could do so by calling on my length operator, and actually no, we just deleted new size, so let's find the length of size. Similarly, let's say I wanted the maximum or minimum. These are all built-in operations that have very efficient implementations. So let's say I wanted the maximum, length, and minimum of size. This is just going to return the appropriate values. In this case, the length of this is just going to return 2. Okay, the length of this, or the maximum of this, is going to return 200, and then the minimum is just going to be 100 in this case. And the last operator that I really want to talk about with regards to tuples is the in operator. So this is a way of checking to see if a tuple or array or list or dictionary contains an element. So it's going to return a true or false value. I'm just going to store it in a variable, so let's call this does contain. And we'll just set this equal to maybe size, or actually let's check to see if the value of 100 is in size. Okay, this is just going to return a true or false value. If we print out does contain, it's just going to, whoops, that's a capital C, it's going to return true in this case because obviously we know 100 is in here. Okay, so if we go ahead and run this, it just returns true there. Okay, good stuff. So that's the basics of tuples. They're fairly straightforward to use. We'd usually just use them to store values, like if we're trying to retrieve output from a function or something, then we might use the tuple for that. Otherwise, we would like to use the more flexible array or list, seeing as we can add or remove elements from arrays and lists, and we can also delete elements from lists as well, or even just modify the contents of an array or list. By the way, like I said, in Python, these are the same thing, whereas in a lot of other languages they're not. So I'm going to use the 2 words interchangeably. So let's consider the next scenario where we have a bunch of movement commands. Okay, this is a very basic game. We're only moving left or right, but we might want to increase the Y position or decrease the Y position by a certain amount. And we have a list of built-in movements. So let's just fill this with some arbitrary numbers. Let's say 5 to the right, 2 to the left. We'll move another 3 to the left, we'll move 4 to the right, and we'll move 1 to the left. Okay, so if we print movement out, it's going to do something very similar to when we printed this out. It will just contain the square brackets instead, denoting that it is an array or a list and not a tuple. And if we want to access individual elements, we again do it based on index. So I could say like first movement is equal to movement array. I really probably should name that something a little different. So movement of 0 would just return my first element. If I were to print this out, this would just contain the value of 5. Okay, so let's say I kind of made a mistake, or I just want to change this for whatever reason. So I want to change this value of 5 to a 7. So what I could do is just select movement. I could access the very first element, and then I could reset this. So I can now set it to 7, and at this point movement is now 7, -2, -3, 4, and -1. It's important to note, however, that first movement is not affected by this change, and that's because first movement has captured the first element of this array at this point in time. Okay, it's not until we reach this line that the array changed. Okay, so first movement does not change here. First movement is still equal to 5. Okay, so the benefit of using lists is the fact that we can not just modify elements, but we can also add or remove elements. So we add elements through the append command, and we'll just say something like movement.append. Let's say we want to stick something onto the end of this list. It should be an integer, although we can actually have lists of mixed types. I could add a string if I wanted. It doesn't make sense in this case. But let's say I wanted to add a negative, we already have a -3. Let's say a -5 onto the end of this, okay? So the results would be that I have my movement array, and it now has a -5 stuck on the end of it. Similarly, I can remove elements by calling on the remove command. So let's just scroll back to here. Let's say I wanted to remove the -3 within my array. I call upon movement.remove, and I pass in the element that I want to remove. Now, weirdly enough, this isn't based on index, this is based on actual value. So now movement would contain, let's just copy this over. Movement now contains all of this stuff just without the -3. Now, this is just a few of the operations. Again, we can perform the length, maximum, and minimum calculation operations in an array or list, just like we would a tuple. And there are, like I said, lots of different other operations we can perform. I don't have time to cover them all, so what I would recommend you do is check out your list or array reference for the Python language, and you'll see a series of other operations that we can perform, such as inserting. We can remove elements at specific indices. We can extend lists, and so on and so forth. However, I do want to move to the topic of dictionaries just so that we can cover them and then quickly wrap this section up. So like I said, arrays and lists and tuples are all accessed by index. So if I want this element 5, I have to know that it's at index 0. Whereas with dictionaries, we store values based on this key value pairing. So I don't store a value at index 0 or index 1 in a dictionary, I store it at a certain key. So let's say in my initial game setup I have a series of starting positions. Let's say I have 3 characters in my game. Let's call them player 0, player 1 and player 2. And I just have a starting X position for each of them. I might want to keep track of these in maybe a dictionary. I'm not necessarily saying that's the best way of doing things, but let's just use that for now. So let's call this starting positions. And this is just going to be a dictionary. We define this through the curly brackets, and then we're just going to provide a key and a value for each of these. So it's a key 1 and value, key 2 and value, and then key 3 and value. So the first key is just going to be something like player 0. Let's call this P0. Okay, I'm just going to copy this and paste it here. It's going to be player 1. Okay, and it's just going to be player 2. Okay. And now I want the actual starting positions. Let's put this guy at 50. Let's put this one at 100. And let's put this one at 150. So you note that for each of the elements, this is actually considered just one element. There is a key, in this case a string, and then the value, in this case an integer. So let's say I wanted the very first element. So rather than calling on my starting positions at the index of 0, okay, I actually call on starting positions at the key of P0. So now if I print this, it will just return me 50. Okay, and again, this is because we're accessing elements based on their key and not on the index. We really don't care where player 0 is located in this dictionary, we just want the value there. Now for the most part, a lot of the operations work the same way, so we can append elements to it, okay, we can remove elements from it. Again, rather than based on the index or the specific value itself, it would be based on key. If we want to append elements, we have to do based on a key value pair. And if we want to remove elements, it's typically based on the actual key provided. We can also calculate stuff like the length, the minimum and maximum just the same way. There's a few additional operations because we do have extra keys and extra values. So let's say I wanted just my starting positions keys. I can say starting positions keys, okay, and then this is just going to get me all my keys. So in this case, it's just going to be player 0, player 1, and player 2, and this returns an array of those. So it would look something like this. Or alternatively, we could just get the values, so replace keys with values, and then you just get an array of 50, 100, and 150, okay? So as with lists and arrays, there are lots of different operations to perform and explore. Unfortunately, I don't have the time to show you and go over all of them, but they're all fairly straightforward, easy enough to use. It's typically the name of the array or the dictionary, whatever, dot, and then the actual operation you want to perform. And various operations will have various parameters that you need to enter. So this is pretty much a conclusion of our collections discussion. Again, I would like to talk more, just don't have the time. We covered tuples, arrays of lists, and dictionaries as well. As always, I would very, very strongly encourage you to do a little bit of practice on your own. Maybe find a new example of a tuple, of an array or a list, and of a dictionary. Try out some of those new operations. And once you're ready to move on, let's start talking about control flow. Hello everyone, and welcome to Python Language Basics Part 4. Now we're going to broach the topic of control flow, and we're going to start by looking at if statements and their variants in this section. In the next section we can focus on while and for loops, but let's just get the concept of control flow down first. Now because this is a new topic, I've started a new text file, or Python file, which I've called controlflowtext.py. The other one that we just finished on was collections text, so if you're not quite done with that, then practice this a bit more. When you're ready to move on, probably best to start a new file. So, what is control flow and how does it work in our code? Well, control flow is just a way to test some kind of a condition and then choose which piece of the code we want to execute based on the outcome of that test. So these tests typically return true or false value. So maybe is some value equal to another that will return true or false? Is some value greater than another? Is some variable equal to true? And so on and so forth. And then if it is true, we execute some code. If it's not true, we can choose to ignore it, or we can execute a different block of code. So in this sense, it allows us to introduce some kind of branching and just general logical testing within the code. So if statements are kind of set up something like this. We have if some kind of condition, and then the colon, and then this is code to execute if condition is true. Okay. If the condition is false, then we can write an else case, but we'll explore how to do that in just a second here. So I want us to first consider this particular example where we're building a game and we have some enemies and we have our character and we have to move from one side of the map to the other without colliding with the enemies. In fact, we're going to build something like this a little later on in this tutorial. So we might want some way to test to see when we move forward if we've collided with the enemy or not. We can use a simple if statement for that, okay? And I'm just going to provide a bit of setup first. So we're going to have a variable is game over. This is going to be equal to false. Obviously, we just started the game at this point, so it's not going to be true. We'll just have like a p0 x position. Okay, I'm only going to focus on the x position for now, and let's set this equal to 0 to start off with. And then we'll have the first enemy, so let's call this e0 x position. Okay, and let's set this equal to 3. So I know this is a very, very simple setup that we have going on here, but basically we're going to increase the player's x position by a certain amount. If this player lands on the same spot as our enemy, then we're going to set is game over equal to true. Well, in order to test that, we'll first have to move the character forwards. So let's say p0 x pos. Actually, I'm going to copy this because I think I'm going to end up repeating this. Okay. So if this is, actually let's increase it by, let's say 2. So let's do plus equals 2. Okay. And then we're going to say if this is equal to this guy here, our enemy's x position, so e and then that, then if this is true, then we want to set is game over equal to true. Okay, and then we'd probably want to carry out some extra endgame logic, make sure that we can restart the game or something. But more on that a little later on in this tutorial. Okay, so this is a pretty simple, straightforward test. We're taking one value, we're seeing if it's equal to another value. If it is equal to if those two values are equal, that means our player character is currently on the enemy character's position, and we want to set game over equal to true. Okay, in this case, this actually evaluates to false because 2 is not equal to 3. So this code does not get executed. We simply skip over this and then execute any code down here. And you'd see that if you print it out is game over, it would still equal to false. If we change this to, let's say 3, then this would evaluate to true, this test here. And so is game over would equal true, and then we'd have to carry out the endgame logic. Okay, let's just change it back to 2. So now let's go one step further, and let's say there's more than one enemy in the game. So let's copy this, we'll paste it, we'll set this equal to E1, and let's set this character's position equal to 5. So now we want to check to see after we move whether we've collided with the first character or the second character. So we can perform two tests, okay? So have another if statement, or we can expand upon this test and say else if. So elif is short for else if. And this is basically a way to perform another test if this first test evaluates to false. So if this first test fails, it returns false, then we'll skip over this code and try this test. So in this case we want to do a very, very similar thing here, and actually I'm just going to copy this code. Okay, else if the player position is equal to e1.x position this time, then again we're going to set game over equal to true. So let's just copy this and we'll just paste it in there. And it's still looking pretty good. But let's say we want to execute some additional code. So let's say for every few steps we take forwards, we want our enemies to move forwards as well. Perhaps we're all moving towards some kind of an end goal. So we do want to increase the enemy's position by just 1, let's say. But we don't want to increase that position by 1 if these evaluate to true, if either of them evaluate to true. Okay, and that's because we've actually reached the end of the game, so we want to pause everything. So for this, we need an additional case called the else case. And this is basically, okay, if all of the above tests fail, we still want to do something, we should execute some code, so we'll have this else case. And then let's just say something like, actually, let's just take these. Okay, and we're just going to let's just bring that in. We're going to set this to plus equals 1, and then plus equals 1 again. Okay, so the way that this would read is we'll increase a player's position by 2. We'll then perform this test. Okay, is the player's position equal to the first enemy's position? Nope, it's not, so we'll skip over this code here, and then we'll try the second test. Okay, are these two equal? Nope, so we'll skip over this code, and then there's some else case or else test to perform, so we'll just execute this code here. However, if any one of these was different, so if we had, let's say this was equal to 3 now, so our player is currently in the same spot as the first enemy, well this evaluates to true, so we execute this code and then we skip everything else. Then we would execute any other code that we have down here. But if any one of the above tests passes, we execute that code and then skip everything else. The else is just really a failsafe to ensure that some code is executed at the end. Okay, so this isn't bad, just out of these comments, but we can actually do a little better than this. We can make it very slightly more efficient. Okay, so note how the outcome of this test, if it's true, is actually the same as the outcome of this test. So either way, we're executing the same code here. So what we can do is combine these into just a single test, and then just have the test being performed in one go, and then have the else case as well. And we can do so using these two special operators, the and the or operators. So let me just actually do the setup, and then I'll explain kind of what's going on here. So I'm just going to copy this code, and we're just going to, I think I missed the if there. Okay, and we're just going to change the setup a bit. So if this equals this, or this code here. Okay, so let's just copy and paste that. Then we're going to do this, and then we can actually take that right out. Okay, so the or operator basically only requires one of these two tests to pass. So we put the or operator between two tests. Same with the and operator actually. But let's first focus on the or operator. So if this test passes, or this test passes, so we only need one of those tests to pass, then we'll execute this code. If both of these tests fail, then we execute this code. If both of the tests pass, that's fine, we still execute this code here. So it's a little different from the AND operator, because using this, we need both of these tests to pass. If either one of them fails, then we skip over this code and execute this code. So the OR operator is actually maybe a better choice in this particular case, because we're executing the same code anyway, and it looks a little cleaner than having the extra case. However, it's not always so black and white as to which one we should be using, so we'll end up using a combination of the if, else if, and else, and then the if with the or and then the else cases. Alright, so at the end of the day, in our particular case, these are actually testing two very similar things, and the outcomes are pretty much exactly the same. But like I said, that's not always the case. Sometimes it's very clearly obvious that we should use this case versus this one, and sometimes vice versa. So if you've never used if statements and else if and else statements before, I would very, very highly recommend that you do some practice with this. It's very important that you grasp the if statement concept before we start talking about loops, because loops use similar concepts here but can be a little more confusing. Also, one last thing, it's important to pay attention to the indentation. So a lot of languages have these curly brackets and then some code in here. That's not the case with Python. It relies entirely on these colons and having the correct indentation. As soon as I have this kind of an indentation here, then this is no longer part of this code. Okay, so important to note that. So just give this a go through. Try some examples of your own. We will be using very, very similar logic to this when we build our actual program, so make sure you got that down. When we come back, we're going to start talking about while and for loops. Hello everyone, and welcome to Python Language Basics Part 5. Here we're going to continue on with control flows, seeing as we've finished with the if statements and their variants, and we'll talk about loops, first covering while loops, then moving to for/in loops. So please do make sure that you're fairly comfortable with the if, else if, and else statement variants before moving on to this section. So for starters, what exactly are loops? Well, loops just provide us a way to execute the same statement or set of statements over and over again, even though we've actually only typed it once and we're running the loop. So this makes them very, very useful for iterating through arrays, as we'll see with for in loops, but in our case, we're going to use while loops to help us update the game. So when you're designing games, it's very important that you understand how the big game loop, there are very often lots of game loops within a game, how they all work. We can use our game loop to, for every single frame, update stuff like player and enemy positions. We can use it to render graphics, to check for stuff like collision. This is all done within a loop that constantly runs as long as the game is running. So let's consider this really, really simple example here. And this is actually going to be a while loop. So we'll say something like while not is game over. So as long as the game is not over, so this is equal to false, then we're just going to do something. So obviously not real code, but let's just pretend there is something here. So the way that this while loop would read is when we're executing the code, we get to this, we read this, is game over equal to true or not? Let's just assume it isn't. So this is going to pass, this test will pass, just like an if statement test. So if this passes, we execute the code here. The difference is, with an if statement, we'd actually execute this code and then exit, and then continue on. With while loops, however, we execute this code and then we loop back up to the top, hence the term loop. We then check to see if this condition is still true. If this still passes, then we'll execute, then we'll go to the top. Check again, if it still passes, execute, and we'll just keep doing this over and over again until this eventually evaluates to false. Once this is false, once this fails, then we'll exit out of the loop. Now the danger here is getting caught in an infinite loop, and this happens when this condition never ever fails. So when you're designing while loops, for in loops actually have a built-in safety check, but when you're designing while loops, be careful to make sure that you will have some exit condition. That means at some point in time that loop will exit, otherwise it will cause your program to crash. So with this in mind, let's actually move to model a very, very similar scenario to what we have going up here, but let's simplify it a little bit. We'll start by checking to see if game is over, and I'd rather not check, I'd actually rather just assert that this is false right off the bat. And then rather than having a player 0 position and an enemy 0, enemy 1, let's just have one player and one enemy. So we'll do p x pos equal to 0 to start off with, and then we'll have an enemy x position. Let's set this equal to, let's say, 3. We also want to reach an end goal. In fact, that's the whole purpose of our game loop here. So we're going to say something like end x pos is going to be equal to 10. So we're trying to get to 10, but we're trying to do so before the enemy gets there, and we're also trying not to collide with the enemy. So we'll actually have to copy some of this logic here. And you know what, I'm just going to write it out by hand rather than copying it because idle's a bit difficult to work with in that sense. So we're just going to say something like if the player x position, player x pos, and apparently I can't type either, is equal to the enemy x position, okay, then in this case we're going to set is game over equal to true. Okay, and that makes sense. We've touched the enemy, we've lost the game. But if we haven't touched the enemy when we've updated our movement, we're going to say if the player x position equals the end x position, and actually to be safe, we should say if it's greater than or equal to the end position, so if we reach it or go past it, then we're going to also set is game over equal to true. But we'll write some extra logic here. And then we'll just say else. If that's not the case, then we'll simply update our positions. So we can say player x position plus equals 1, and then the enemy x position plus equals 1 as well. Now, this won't get us very far, so let's actually modify this to 2. Perfect, way better. Now, what we also want to do is execute some different statement, because either way, if we win or we lose, the game is over. But perhaps we want to print something like you lose here, because we've touched the enemy, so you lose, okay? Whereas we want to print something like you win if you win, okay? So there we go. Now realistically, if we wanted to model the game exactly, we would also check to see if the enemy reaches her first, but let's just roll with this for now. I mean, we're not actually implementing the full game logic yet, although we'll do something kind of similar to this when we implement our real game. So what we can do is actually go ahead and run this. So we'll do a function f5, and let's see how this goes. Okay, so we get you lose, but we don't know exactly when we were hit. We just know that with these starting positions, eventually we end up losing. So let's try a variety of different x positions. Let's see if we can win at some point in time, with some various combination here. Okay, so let's just say okay. We lose again. Let's say if we start at position 2, I'm pretty sure that's going to be a loss as well, but let's check it out. Okay, yep, we still lose. And so it seems like we're just not going to be able to win this one. So let's increase our player position to, or our speed to plus equals 3. And then if we run this again, hopefully we should actually win this time. Yeah, there we go. Okay, finally we won. Okay, but you hopefully get the whole concept of the loop. Now it's hard to see each loop iteration here because we're not printing something out every single time. So let's print out our player x position. Okay, so p x pos. And let's also print out our enemy x position, so enemy x pos. Okay, so that way when we go to run this, oops, that's 5, I want F5 instead. Let's give it a save. There we go, we get the actual positions being printed out there. So now hopefully it's a little clear exactly how this is working. Basically we'll start out by seeing if the game is over. Okay, it's not over, so this equals false, so this test passes. We're just going to print the positions, then we're going to perform the check. Okay, that fails. We'll perform this check, that also fails, so we'll increase the positions. Then we loop back up to the top, we do it again, and then again, and then again, and then finally we reach the end position, so our player x position is equal to 11 at this point, which is indeed greater than or equal to our end position before the enemy reaches there, so yes, we do indeed win. Alright, so that is a basic while loop for you. It actually works very, very similar to an if statement. It's just instead of only executing once and exiting, it executes over and over and over again until this eventually evaluates to false. By the way, you can speed things up, like you can move on to the next loop iteration by using a continue statement, or you can break out early from the loop, so exit early by using a break statement. Okay, so that is while loops for you. Now let's take a quick look at for in loops. So let's run with something even simpler than this, and let's just consider the scenario where we have a bunch of movement commands. So I'm really going to simplify and just have an x position variable. That's all there is. So we'll start off at, let's say, position 5, and let's say we have a list of movement commands. Let me just give myself a bit more space there. So we'll have a series of movements. This is just a list of a few movements, perhaps forward 1, back 2, forward 6, back 3, back 2, and then perhaps forward 4 or something. So we have a series of movement commands and we want to execute them and end up with some kind of an x position which we'd like to print at the end. Now we can do this by saying x position plus equals movements of 0, then movements of 1, then movements of 2, and that's okay. I mean, we only have 6 elements in this array, so it wouldn't take very long. However, if we had 1,000 elements in this array, it would take us hours to print all that stuff out, or to write all that code. So we can just actually put this in a loop, write maybe a few lines of code, set it running, and it will do all the work for us. And the easiest way to do this is with a for in loop. For in loops are built for working with ranges of numbers or with lists or arrays like we have here. So what we could do is say something like for movement in movements, and just bear with me here, I'll write it out then explain the syntax in a second. We're just going to say xpos plus equals movement, and then at the very end of this iteration we're simply going to print out the x position. Okay, so before we set this to running, let me just explain what's going on. So the for in loop works to say for every single element in this array. We can replace this with a range of numbers, we can use an array or a tuple or something like this, but it will start at the very beginning of this list and it will visit every single element until the very end, at which point it automatically exits. So you can't really go out of bounds with this guy unless you're really messing around with the interior here. So what this will do is it will start at the very first element and it will say, okay, we'll create this variable called movement. We're going to set it equal to the value of the first index, or the 0th index I should say. We're going to say x position plus equals whatever value it finds, and then it's going to go back up to the top, and then it will increase the counter by 1 to move to the second element. Then movement equals -2, it's going to add that, then it's going to move to the third element, 6. It adds that to x position, and so on and so forth till it reaches the final one. It will add that to x position, and then it will exit out of our loop. So if we go ahead and run this now, I mean, we'll get all the old code being printed out too, but then we also get that final number 9, which is our final x position. And I'm sure if you add these all together to 5, you will eventually get 9. But that's basically how for in loops work. So they're actually very simple to use. I would very much recommend using these with arrays, but only really when you want to visit every single element. Sometimes you don't want to visit every element within an array. Sometimes you might want to start halfway through. That is the restriction with for in loops, is that it does visit every element, starting at the beginning and finishing at the very end. So very practical, easy to use, a little bit less easy to use, but a lot more flexibility. So if there's going to be any section in which you spend the most time practicing, it is going to be with while and for in loops. So I'd very, very strongly recommend you take a few minutes and try some more examples on your own. So come up with another good example of a while loop, maybe try to mimic a different scenario, and then the same with a for in loop. And then once you're comfortable, we'll actually move on to a brand new topic, which is going to be on functions.